Today's problem was submitted by a viewer, and it says, given a positive constant k, suppose a real non-negative sequence an satisfies am plus n is less than or equal to am plus an plus k for all m and n natural numbers. Show that an over n is convergent. Okay. So we have a positive constant. We have an is non-negative. And the condition we're given is that a of m plus n is less than or equal to am plus an plus k for all m and n. We want to show that an over n converges. Okay, so what does this condition look like for a fixed value of m or n? Like, what if m is equal to 1? Another thing I'm thinking is maybe if we assume that this does not converge, that means we can find a subsequence of an that grows faster than linear. And then maybe we could find a contradiction to this statement. Is there any sense in iterating this? What happens if we iterate this and write this as, so write a m plus 2 is less than or equal to a m plus 1 plus a1 plus k. So this might work, right? We can see that the thing is growing essentially linearly, right? So at most linearly. Make sure I did this right. am plus 2 is less than that. That's just this statement written for m plus 1. And then this, I can sub that in for it. Okay, yep. So I have something like a am plus k is going to be less than or equal to am plus k a1. I shouldn't use k here. M plus n is less than or equal to am plus n a1 plus n k. That's just iterating this thing. I'm not going to explain exactly how that comes. It wouldn't be too difficult to work that out. We basically use this and keep fiddling with the indices the way that I went from here to here. Okay, so this says that am plus n so fix m. In fact, let's let m be equal to 1. So now I have a of n plus 1 is less than or equal to a1 plus n a1 plus n k. So this is less than or equal to n plus 1 a1 plus n k. So a n plus 1 over n plus 1 is less than or equal to a1 plus nk over n plus 1. Oh, this doesn't say it converges, right? This just says that it shows that it's bounded by essentially it puts a bound on the sequence, right? I mean, I think we can kind of combine this this line here with my previous statement. Suppose an over n does not converge. Okay, then there should be a subsequence, we'll call it nk, such that a and k is bigger than something of this form. I think. I mean, I'd have to work out the details. Maybe it's worth actually doing this in a detailed way. Like if we could show this, if we can show there's a subsequence which grows faster than linear, and this would be for all alpha and beta greater than 0. If this is true for all alpha beta greater than 0, then that clearly contradicts this. Right, suppose, I mean, seems like a lot of the things that I'm doing here show that doesn't show that the limit converges. It just shows that the limit will have the sequence will have linear growth. But these terms could still jump around all over the place. I'm not totally sure. I don't want to spend forever on this. I feel like I'm going to run in circles. I don't know if this is, the best thing to do, but you can see some of this linear structure coming out that, the sequence has at most linear growth. But that doesn't necessarily mean that this converges. It means that, it can't grow forever. This thing will be bounded, but it doesn't mean it converges. I'm not going to go too much more in detail on this one. I've been told that this is an Olympiad level problem, so you know, I can't really expect to be able to figure this one out. Yeah, I think I'll end this one here, but thanks for watching.